Good afternoon, class. So this is a quick introduction into hexadecimal numbers. So I'm borrowing a little chart from another school. Hexadecimal numbers are what you call base 16. What we're used to thinking of is in base 10 or decimal, as you can see right here. Oops, decimal here. So in decimal we count usually from 0 and then it flips over after 9 to 1 plus 0 and continues. So base 16 means that we go from 0 to 15 is the equivalent in decimal. So hexadecimal is base 16, so we go from 0 to 9. And then when we get to the equivalent of 10, we don't write 10, we write A, B, C, D, E, F. And this also can be represented in binary. This is the sign representation. What this means, the sign representation, what this means is if you look at, let's say, -8 here, the most significant bit on the far left of the binary representation, or the fourth bit, is actually, if there's a 1 here, this represents -8. The third place represents +4, second place +2, and the first one is +1. So if we look at this number right here, we have 1 plus 0 times 2 plus 1 times 4 minus 8. So we have plus 5 minus 8, which is minus 3. There's a link to this web page that's attached to the pre-lab. In the pre-lab, I include an image that looks like this. Basically what I've done for this video is I've wired the MyDAQ. So these are the digital input-output pins. I'm treating pins 1 through 0 through 3 as my digital output pins, and 4 through 7 as my digital input pins, so I can read that. So like, as you can see, I hooked up 0 to 4 with this black wire. I hooked 1 up to 5 with this red wire, and I hooked up 2 to 6 with this orange wire, and 3 to 7 with this purple wire. So this right here, the digital output, basically I'm using 0 to 3 as my digital output, and I'm using 4 to 7 for my digital input. Now the reason why I'm giving you guys an introduction to this is in the lab it'll actually be very wise to check your digital logic with using the MyDAQ. You'll be required to simulate some circuits further down in this lab, and then you can actually check them when you start building them. So the MyDAQ comes with it comes with the digital write, or you can think of this as the digital output, and it comes with a digital reader. The reason why I introduced you to HEX is I can plug in A right here, and if we go back, A represents 10. So if we go back here, A is 1010, and it represents 10 here, or -6 if you're doing sign. But if you notice, this one is lit up and this one's lit up. Pulled this one high and that one high. So you can type in the hexadecimal equivalent right here, and I'll change it to binary. As you can see, so it'll actually tell you what the hexadecimal equivalent is. So if I flip the first bit 0 is lighting up here and bit 4 is lighting up here, because what I'm doing is I have these guys wired. So basically this guy lights, so when I press 0, pin 4 lights up. When I press 1, pin 5 lights up. When I press 2, pin 6 lights up. When I press 3, pin 7 lights up. Now one thing you don't want to do is you can either read or write. You cannot do the same thing. So if I click on the reader telling it to read from all 7, you'll get an error, because right now I am writing to 0 to 3. So you need to keep this in mind. So anyway, so if I go here and I type in F, now if I had all 8 pins connected, I could go A, F, and what that would do is it would write A to this first part and F to this second part. Basically you can use hex to represent every 4 bits. But right now I don't have a setup where I can actually film and show what's going on. But if I type in A, B, C, D, E, and F. So, and then of course you can go 0, 1, 2, 3, 4, and so on and so forth. Now there's more options. You can also rotate the bit. So basically this will take this one bit and it'll rotate it. It'll keep rotating it. Now the shift will shift and then it'll eventually disappear. So you can control which way it's going. You can toggle. So if I had one like this, one bit up, it would just flip all of them. And anyways, this is a very good way to go through and double check the logic for your circuits in future work. Anyways, this is the end of this quick introduction.